I want to talk about chokes today because I made what they call an ugly balun, right? I don't like the name, but whatever. I made one of these originally when I put the 20-metre dipole up. And since then, I've been making ferrite cord chokes. I've got one on the 3 Yagis outside. Let me just explain about coax, first of all. So, coax, I know we think of coax as effectively 2 wires. You know, we've got the inside and we've got the outside. In other words, we've got the centre core of the coax and we have the braid of the coax. And fundamentally, our AC, if you like, comes up the coax, up the centre core and the inside of the braid. I don't know what coax this is. It's a little 5mm stuff. Let's not panic about that. All right, the inside of the braid. And we get this opposite and equal reaction going on between the very centre core and the braid. So what happens is, effectively, our RF, the AC, right, comes flying up the inside of the coax, right, and it gets to the antenna. Right, now when it gets to the antenna, it has a decision to make. If it's a very well balanced, say, dipole, when I say balanced, I mean each end is exactly the right size. It's not next to anything metal or conductive or a really big tree that's full of water or something. Most of the RF will just flow across the dipole and get pushed out into the ether, right? Any slight imbalance and the feeder, right, becomes a third leg. So if we've got the center of the coax going this way and the braid of the coax going this way, this can become that side of the dipole. So to stop that happening, we use a choke, and there is 1,000 different ways of doing it, and the only 2 that I recommend is either an ugly balun, which is just some coax, a wound round, paint tin or something, take the tin away afterwards, bit of tape and whatever, or round a ferrite core. That supplies effectively a high impedance to this bit. So now what happens is the RF comes along to your dipole or Yagi or whatever else, and it goes, oh, I'm a little bit out imbalanced. Where can I go? Oh, I'll go back down the coax. Oh, shit, I can't. Right? It chokes in the way. Right. So, back to the beginning, right? I use only about somewhere between 1,000 and 2,000 ohms impedance. It's just a number, right? We'll come back to that in a minute. On my 15 and 20 metre Yagi, and probably a little bit higher on my 10 metre Yagi. Only 1,000 on 20 metres. I know, because it's a 2-element dipole, effectively. 2-element Yagi with a reflector. It's up high in the air. It was cut by me really accurately to the millimetre. There's very little, this is called the outside stuff that comes back down. It's called common mode current. Very little common mode current anyway. I know, right? I mean, I haven't measured it or anything, but I just know. Therefore, I used 2 FT 43 452s. So it was, I can't remember. I'll find a spec and put it on the screen. Just 2 ferrite cores, and I put coax 4 times around it, which I knew would give me a little bit of choking. Not a lot, right? But a little bit is all I needed. Where did I get the inspiration from all this? Come over to here for me, with me. This project was done by G3TXQ. He's silent key now, a fella called Steve, and he did a huge amount of work. And he said that we've got ferrite cord. Oh, I've got a 240 52s they are, right? So that's what I've got. He did this project on FT 240 43s. 240 means 2.4 inches. That's all, right? So he said, let's go down to the air cord. I was on 20 metre band, which was megahertz, roughly just under this line here. And I chose, I think about here, 15 turns RG58 on a 5¼ inch air cord former, right? And then I look at the chart here, and that gave me 8,000 ohms. A hell of a lot, right? And the reality is, I probably only need somewhere between orange and yellow, somewhere between 1,000 and 2,000. And I'm on a ferrite core. So if we look down this ferrite core, I mean, this is all sorts of stuff here. He's got 6 on these beads and all sorts of stuff. Very high impedance, 12 turns, RG58 on a 240/61. He was getting enormous amounts of choking. And I just thought, well, 4 turns, I'll get about 1,000. And I've done the maths. It's probably actually only about 800 to somewhere between 800 and 1,200 choking ohms impedance on 20 meters, and double that on 21. But I'm happy with that. But anyway, this chart here, I'll put a link in the description. And just remember, if you are putting up a dipole, then best practice will be to have a choke, because this common mode stuff that comes down the outside of the coax won't stop. It'll keep coming down and down and down and down. It can come all the way back to your radio, and all of a sudden your mouse stops working, or you can hear yourself in your loudspeakers and all sorts of things. Not necessarily, by the way, high SWR. It might be very balanced. I'm not talking about balanced and unbalanced in terms of ladder line and coax. I'm just talking about balanced in terms of its physical size and its the counteraction it has with other objects nearby. Balanced, all right? If it is in the air and it's miles from anything and it's very balanced, chances are you may not get any common mode current coming back down here. Let me move over to here. So we don't necessarily need to look at low or high SWR. You could have high SWR and next to no common mode choking. I know most of my antennas are very well balanced. I cut everything very accurately. I've got a very high impedance choke on the 160 80 meter fan dipole. In fact, I can tell you, it's if you look at that very top bar, I think I've got about 17 turns of the equivalent of RG58. It's not. I think it's this stuff, which is AirCell 5. I think it is. It's not. It's less than the size of a pencil. Because that will be quite unbalanced in the future. I've got to cut one leg off it and put it on the other side. So I'm talking unbalanced in a physical kind of format. So not necessarily high SWR, although low SWR will help, but not necessarily. You can still have common mode current coming down the outside of your coax, ruining your power, sending it where you don't want to be, and also picking up rubbish on the noise front. That is the truth about chokes, ugly balance, and other things. See you next time. All the best. Bye for now.